Hello everyone, my name is Prosenjit Mondal. My student ID is 21020449. Today I am presenting my analysis on fundamental internet protocol, analyzing DNS queries with Wireshark. To start, let's define the problem that DNS solves. As human, we interact with internet using simple memorable name like www.google.com, facebook.com, youtube.com. But computer and network, however, communicate using number or numeric number like IP address like 142.250.190.78. How does our browser find the right computer on the internet just by using a name? To find the solution to the problem is the domain name system or DNS. The domain name system or DNS is the phone book or massive internet global and distributed system that translate human friendly domain name into the machine readable IP address required for network communication. This translation process is the starting point for almost everything we do online. So, why is the topic important for us to understand? Firstly, DNS is the absolute fundamental of the internet. As I mentioned, nearly every internet action, browsing, sending or an email or playing game start with DNS queries. Being with a DNS query, without it, the internet as we know it would not work. Second, for network engineer, it's critical troubleshooting tool. It always DNS analysis queries help diagnose network failure. Third, the major security aspect. Most standard DNS traffic is unencrypted. This is a privacy concern, but it also means we can analyze the DNS log to find security threat, like a piece of malware on a computer trying to contact its hidden command and control server. And finally, performance. A slow DNS lookup directly translates to a slow loading website. Analysis help identify and fix these performance bottlenecks. For my analysis, I used simple and practical methodology which involve these three parts. First, the main tool is Wireshark. Wireshark is a free open source package analysis analyzer. It essential act like microscope for your network, capturing and displaying all the traffic passing through your network card. This allows us to see individual protocol like DNS in action. Second, to generate the traffic for our analysis, I use a simple command line tool called DNS lookup. You can also generate this traffic by simple visiting a website in your browsing, but DNS lookup is a very direct way to ask the system to perform a DNS query. And third, finally, the process itself is straightforward. First, I start the Wireshark capture. Second, I run the NS lookup test. Third, I stop the capture. And fourth, this is the most important part. I apply the display filter DNS to hide all other network noise and focus only on the packet we care about. Before we look at the packet, it's important to understand the basic process which is shown in this diagram. It starts when your PC sends what is called a recursive query to your local DNS server. This is usually your home router or your internet service provider service server. Your PC is essentially asking, I need the address for such as www.google.com, query equal google.com. Please find it for me. The local server then take responsibility and perform iterative queries on behalf. As you can see in the diagram, it first asks the root server, which does not know the full answer, but it points the way. It say, I don't know, but I know the TLD server for the .com domain. Go ask them. The local server then asks the TLD server, which also does not know the full answer, but it points the next step. It say, I don't know, but I know the authoritative server for google.com. Finally, the local server asks the authoritative server, which does know the answer. It provides the final IP address. This address is then sent all the way back to your PC, and the query is complete. There are just a few more concepts to know. When your computer makes a query, it asks for a specific record type. The most common one is an A record, which map a name to an IPv4, AAA record, which map a name to an IPv6 address, CNAME, and at least that point to another domain name, and other like CNAME, MX, specific the mail server for a domain name. The other key concept is transport protocol. DNS primarily use UDP, User Datagram Protocol, on port 53. Why UDP? It's fast, low overhead, and connectionless. A single request and its response can fit its own packages, which is highly efficient. Okay, so now let's move to the practical analysis. This is the screenshot of my main Wireshark interface after I have run my test and applied the DNS filter. As you can see the top, the DNS filter is active. In the main packet list, we can clearly see the two packets we are inter, interested in. First, standard query from my PC, and second, a standard query response from the DNS server. The information column gives us quick summary, and we can also see the source and destination IP address. Now let's look closer at the first packet, the query. In this screenshot, I have select that query packet, and in middle packet detail pane, I have expand the domain name system section. We see the flag and identify this as a standard query. And the most important, under the queries drop down, we can see exactly what we are asking for, the name. The query www.google.com, and what asking for the type A record, which as we just discussed means an IPv4 address. Following that query, we have the response. I have now select the second packet. The second packet detail, we can see this is a response and information column confirm this. The most important part in this answer is the answer selection. When I expand this, we see the server has provided the answer. It says the name www.google.com, query equal www.google.com, has a type A record with the address 142.250.190.78, and that's it. This is the IP address of browser would now use to contact Google server. The translation is complete. So what we can conclude from this analysis? What are the practical implications? First, let's talk about performance. By looking at the timestamp in Wireshark show in the specific screenshot, but are in we can see the entire process from my PC sending the query to receiving the response often take less than 50 milliseconds. This is incredible fast, and this speed is essential for making the internet feel responsive. Second, a key implication is security. As we saw, all the information was sent is clear text. Anyone on my network could see exactly what website I am looking up. This is the major privacy flaw, and it's primarily reason why new encryption protocol like DNS over HTTPS have been invented and are now being adapted by browsers. To conclude my presentation, we have discussed that DNS is essential translation service of the internet turning name into IP. The main takeaway is that a powerful and practical tool that make this complex invisible protocol to visible, allowing us to analyze the query response flow, diagnose issue, and understand its performance. That's bring me to the end of my presentation. Thank you very much for your time and attention.